students, Miss Ward here with our introductory lesson into the Earth's atmosphere. So as a reminder, the atmosphere is that thin layer of gases that surround our planet Earth. And it's also going to be the topic of our lessons for the next few weeks. Now moving on, we're going to talk about what makes our atmosphere up. Of course, we know it's gases, but one of the common misconceptions is that the Earth's atmosphere is made up solely of oxygen, when in fact oxygen is actually only about 21%, or this says 20.6, but we'll round it up, 21% of our Earth's atmosphere. The most abundant or the most common gas you'll see is actually nitrogen, which is 78%, which is a little over 3/4 of our Earth's atmosphere. Finally, we have one last column that we list as other, and we call it other because there are so many gases listed here on the right. It's hard to list those out every time we want to talk about the Earth's atmosphere. It goes the whole way down from argon, water vapor, carbon dioxide, the whole way down to the last in the column being CFCs. So we put these in the other category. One thing I did want to note is if you look at this slide, you can see that some of these other gases are starred, and at the bottom it says known greenhouse gas. We're going to talk a lot more about greenhouse gases as we move through the unit, but for now, we're going to go ahead and just make note that there are some gases that are in trace amounts in our atmosphere. Now, this is a portion of the slides where you probably want to pause so that you can record this information in your science notebook. This is breaking down what you just saw in the previous slide about the composition up in the air. So again, 78% of the atmosphere is made up of nitrogen, 21% is made up of oxygen, and 1% is all those other gases, the argon, the carbon dioxide, water vapor, and all the greenhouse gases that were noted in the last graphic. Now, one of the things that I think is really important to note, this part about nitrogen is really common to be asked that on either a test or either for my class or for sometimes you may even see on a state test. Remember, it's really, many students get very confused and they want to say oxygen is the most abundant, but remember it is nitrogen is our most abundant gas in the atmosphere. Now, one of the things I just really enjoy when talking about the Earth's atmosphere is talking about how special it is, how unique our atmosphere is in that it can sustain life on our planet. One of the, if not the most important reason why we have life here on Earth is that we have an atmosphere that can sustain life. So when we talk about the Goldilocks principle, we look at our two closest neighbors. We have Venus, which is one planet away from us, closer to the sun. It is the second planet from the sun. And then we have Mars, which is also a neighbor to Earth, but it is one more planet away from the Earth. So we have Venus being the second, Earth the third, and Mars the fourth away from the sun. When we look at Venus, it has a high concentration of carbon dioxide gas, but what it also has is a very dense, thick atmosphere that holds in heat. So Venus is very, very hot, so hot that it does not sustain life on its planet with that thick, hot atmosphere. So Venus is too hot. Then we have Mars on the opposite. Now, while Mars does have a high level in comparison to the other gases of carbon dioxide, its atmosphere is very, very thin. And it is very cold on Mars. So we know Mars is too cold. Here, right in the middle, we have our home planet Earth, which is just right. It has the perfect atmosphere and the perfect temperatures, which allow us to live and all life on Earth to exist. So Earth has the just right characteristics that allow life to exist. Now, it's very, very important when we're talking about our unit on the atmosphere to recognize some of the important vocabulary that we'll see throughout the unit. So again, this is highlighted in red, so I would record this information. When we look at density, many of you Really, all of you should have at some point in your academics come across the word density. Density is the amount or the mass per unit of volume, or the amount of stuff that's in an area, in a unit of volume. So often you will see this written as a formula: density equals mass divided by volume. So there's a relationship between mass and volume that creates density. Things that are more dense have more stuff in the unit of volume, and things that are less dense have less stuff in that unit of volume. And by stuff, I'm referring to matter. Altitude. Often you will see this written as elevation as well. They, at this point in your academic careers, can be used interchangeably, but in atmosphere we really prefer to use the word altitude because it's the distance above sea level when we're talking about the atmosphere. So areas that have high altitude are further away from sea level, and areas that have low altitude are parts of our atmosphere which are closer to sea level or closer to the surface of the earth at ocean level. And finally, air pressure. Air pressure is the force that's exerted by air on any surface that's in contact with it. Air pressure is going to be key when we are talking about weather and how to predict weather. So we want to go ahead and acknowledge and talk about air pressure as an important part of our Earth's atmosphere. Now, again, this is a point in which you probably want to pause and record this information because this is going to be a stepping stone to explain how air molecules and density are, the density of air molecules change with altitude. So one of the things that's you easily forget because you can't see air is that air does have mass because it's made up of molecules of gas. Again, that nitrogen, the oxygen, all the other gases. Because it has a mass, gravity is going to exert a force on them, and they're going to be pulled closer and closer to the surface of the earth, and they're held there by Earth's gravity. So again, this needs to be recorded in your notebook, and now we're going to move on to our final slide. There is a lot of fantastic information in this chart, and this chart really is going to break down the relationship between altitude and density, which is really, really important to understanding the atmosphere, and one of the major concepts that you will need to know coming out of this unit. At sea level, at an area close to the ground, so right where the oceans lie, you have the highest level of pressure, the highest level. The molecules are held very, very, very tight together in comparison with other parts of the atmosphere. And that's because the gravity is pulling the molecules of air closer to the surface of the earth. Now, I decided to highlight Mount Mitchell right there on the Blue Ridge Parkway because it's the highest peak in North Carolina. The air pressure, because it's a little bit higher, is lower. The molecules are not as tight together because you are moving away from the Earth's surface. So the gravitational pull is not going to be quite as strong at the top of Mount Mitchell as it is at sea level. We're all familiar with that huge mountain, Mount Everest. It's the highest peak on our planet. It is so high that the molecules do not hardly have any gravitational pull, or as much gravitational pull on them, So the air pressure there is very, very low. And the molecules, the density of the molecules, they're very, very far apart. So much so it's quite difficult to breathe air. The oxygen molecules, they're not as much, so it's very, very difficult to breathe, and it takes months and months and months of conditioning to be able to reach the peak of Mount Everest, and it has to be done with the aid of oxygen tanks. But again, Mount Everest is the highest peak on Earth and has very, very low density. Finally, the thermosphere. No, you do not know the word thermosphere quite yet. That's pretty much in the gist of it. It's the edge of space. It's the very outer rim of our atmosphere. And so at that point, with the low gravitational pull, you have pretty much a non-existent air pressure, and the molecules are so far apart, they're really not even there. So I wanted to keep this video right at 10 minutes, so I'm going to go ahead and wrap it up. And again, please make sure you have all the items that should be recorded in your science notebook. Thanks again.